This is an HP Mini 210-2000 notebook. It's got a 10.1 inch screen, 2GB of RAM and a 1.66 GHz CPU with integrated graphics, and it weighs 1.5 kilograms. The only thing it's capable of is word processing, if it's used on Windows. With Linux, this baby becomes the little laptop that could. But first, I need to make sure that the thermals don't run too hot. As I didn't have any compressed air available, I needed to try some alternative methods to try and remove dust. Nothing worked. Anyway, I've taken an interest in security research, particularly IoT devices. This laptop has Ethernet support with an actual keyboard switch to disable the NIC, making it ideal for a researcher. To install Cali, I found an old USB lying around and used a formatting tool called Rufus to put the image on the stick. I then changed the laptop's BIOS settings to boot from USB first, and from the hard disk last. But first, I let Windows play a song to itself. Booting into the flash drive lets us install Cali. Hooray! But it takes 2.5 hours. Not good. What is good, however, is that it works without a hitch. Terminal? Easy. Web browser? Who needs one? With a quick update run, I was ready to start having a bit of fun with some of my devices. Enter the Roku LT, advertised as being all you need to stream almost anything on your TV. Streaming companies write channels for the device so that people without a smart TV can still watch. It's now a couple of years old and not patched very frequently. I wanted to play around and find out if it was vulnerable in any way. The first step was to run an Nmap scan to determine the services available on the device. Initially there was an HTTP proxy service on port 8060. Going to it led to an XML page that threw out more information about the device and its offered services. This was just the root page. More directories were looked for using Dirtbuster. While I didn't have the processing power required to complete the word list in a decent amount of time, some pages gave out a 400 bad request error, which implied that the page did exist, but the page required certain headers on top of the GET request, or that it only accepted other verbs. Writing a short Python script to test different verbs didn't work, unfortunately, giving similar 400 responses. While nothing was found by Dirtbuster, there were existing clues on the root. These two XML files weren't particularly useful, but attempting to access invalid XML files gave a parsing error instead of a 404, implying that the box is potentially vulnerable to an XML external entity attack. Potentially. I now fully appreciate the skills and talents of security researchers. I imagine so many have hit a brick wall and spent days trying everything possible to find that elusive 0 day. Which is why I entered the Konami code for the box's developer mode. It's a little bit like cheating, but it does open a bunch of new ports on the box and a similar number of questions. Could you send the same sequence of inputs with a universal remote? Yes, you can. Can you enable developer mode without the TV being turned on? Absolutely. So, anyone with line of sight to the box could enable this without the owner knowing. All you have to do is set a 4-character or longer password. This password can be reset by repeating the Konami code. Renavigating to the box's IP on port 80 reveals a developer console of sorts. You can upload your own channels to the box and take screenshots when they are not browsing any particular channel. As soon as the install button is pressed, the box immediately jumps to the new channel, making it possible to use this functionality as a crude denial of service attack. I suppose this is still hard to exploit, since you need to be on the network first. So, in conclusion, I need a lot more experience with security research, but I can't wait to learn new techniques. This little laptop will be coming with me frequently.